Today I'll talk about some works I did in Yonsei University. Actually, with Professor Sang-hee Chu as well, and Professor Bae-won Kim, not in this room, but he was presenting a few hours ago. So anyway, the title, I made it Enhancing Mental Health Care with Large Language Models. Actually, I didn't know anything about mental health care before I joined Yonsei University, but thanks to Professor Sang-hee Chu, I started working on that. So first, I'll start the discussion by introducing the LLM, and after that, I'll talk our recent works on using LLMs for mental health care applications. So we have three papers actually, and of course, some of them are under review. But first paper is about diagnosing mental health disorder using LLMs, and second and third one is about cognitive distortion. So let's start with the history of AI and machine learning and LLM, how LLM evolved in this history. So actually, machine learning and AI it started quite long ago. So basically, 1950s, there was first AI boom. So AI is formally defined in 1950s. And after that, there were first AI winter because the idea is quite good, but there were not many things we can do at that time. So thanks to the big data era and huge computation ability, we moved to the second AI boom. So basically, in year 1989, this was the probably first service that AI could help our life. So basically, LeNet was introduced. So LeNet is a network that is developed by Yann LeCun. Yann LeCun is a French-American computer scientist. So he developed a network called LeNet. And this LeNet is developed for classification task for MNIST data. So I'll show what MNIST is and how things work in a few slides. But anyway, we also had second AI winter after that. So anyway, there are many different types of developments afterwards, but LLMs, the era of LLMs only started within 8 years. So basically, the architecture called Transformer is introduced in 2017, and I guess many of you already know, but ChatGPT is released in 2022. And after that, what happened in 2025, I'll introduce what humanities last exam is and how surprising it is. So back in 1980s, this was the state-of-the-art service. So if you search over YouTube, type 1989 LeNet MNIST classification, then you can see the left-hand side video. So this video is uploaded by Yann LeCun himself, and basically what he did is basically given the handwritten digits, he let the computer recognize which digit is in the handwritten version. So in this case, we have 4627, which is correctly estimated on the right-hand side slide. So this was the state-of-the-art service around 40 years ago. But nowadays, as I mentioned before, we have some data set called Humanities Last Exam, written in the right bottom here, there. So people call it HLE. So the title of this benchmark is named after the concept that this is the last exam a human can make to test machines. So basically, we cannot make any more difficult exam than that. So how difficult is this exam? So actually, on the left-hand side, we can see some example of Roman encrypted text, maybe. And I have no idea how to decrypt it. Yeah. And of course, I'm not majoring in history, so maybe I cannot solve this one, but probably I like math, so on the right-hand side, I found one sample in this humanities last exam. But even though I like math, I cannot solve this right-hand side math problem. So actually, you can know that this is quite difficult problem, but actually the SOTA model, state-of-the-art model, machine learning model, they achieve around 30% accuracy on this HLE benchmark. So anyway, the advent of AI is quite surprising. And more than that, this artificial general intelligence, AGI, is just around the corner. So basically, this is the introduction of some service called, I cannot remember the name, but basically, it is solving international mathematical Olympiad problems. Of course, who cares? Yeah, we are not from International Mathematical Olympiad. And maybe you do not care, but it was quite surprising because many of my friends were very good mathematicians and they couldn't solve IMO problems. But AGI, so AI can solve these problems quite well, and it achieved the silver medal standard solving these IMO problems. So on the right-hand side, you can see the score of AI is around 28 points, and it is right before the gold medal threshold. So this is why I'm believing that AGI is just around the corner, and more than that, this is reported last year, and this is the IQ test for the large language models, LLMs. So before the advent of OpenAI O1 model, all other models had IQ with 2 digits. But O1 model reached 120 and I believe that latest models are having much more higher IQ. Of course, IQ is not the sole only metric for measuring the intelligence, but more than that, this is something I want to introduce. So deep research is, I believe, something that any researcher should use, which is basically searching over a bunch of documents and then writing the report in a few minutes. So actually, if I write some papers or find the related works, literature search, and even writing some research proposals, I search over this bunch of documents and then use this in daily lives. And actually, this all started with the advent of large language models, and that is why I'm interested in this topic. All right, I guess many of you already know, but let me briefly introduce the basic concept of language modeling. So basically, language modeling is started with questioning what is the most likely missing word when we are given the blue part. So actually, I should have the animation, but basically, I give the blue part, and I ask GPT or machines to estimate what is the upcoming token or upcoming word. So the upcoming word is written as red color there. And basically, blue one is what we call prompt. So we put prompt to the LLM, and then this large language model is estimating how to complete the sentence. So that is why we call it completion versus prompt. So basically, it is often viewed as a probabilistic behavior. We estimate the probability of next word given the previous context. So it is nothing but estimating probability of y given x. So this conditional probability is well learned in the ChatGPT and related other language models. So language model is basically a model that attempts to generate sentences that sound typical to us. So this is the basic concept. And now the question is how these surprising things happen. So how are LLMs trained? So actually, as I mentioned before, language modeling is nothing but next word prediction. So actually, this is quite surprising and powerful ability because I guess you are you're listening my talk, and if you can estimate my next word, then you need not take my lecture, right? Yeah, because you can estimate next word and so on. So it is quite powerful ability. And how LLMs are trained, basically, of course, this is some controversial things OpenAI did, but OpenAI crawled from internet a bunch of paragraphs. And then the left-hand side, brown shaded region here, is one example of some paragraph I crawled from internet. So I'm working on machine learning theory, so new ML theory and methods to enable, blah, blah, blah. And after crawling it, LLM researchers, they parsed this paragraph into multiple X and Y pairs. So in the first line, you can see that, okay, if new is the given token or given word, then the next word is ML. So X is given, then Y is the next word. And similarly, if new ML is the token sequence or word sequence we observe, then the next word is theory. So in this way, we can make a bunch of pairs coming out from this paragraph scroll from internet. And actually, GPT-3 is trained on 500 billion pairs, which is quite amazing amount of pairs. And they put it into this architecture called transformer, and then train it. And after train it, what they observed is they put some new sentence called, in this example, medicine is a city in. Then LLMs can estimate the state that medicine is in, which is Wisconsin. So this is some basic train procedure and then just inference procedure on the right-hand side. And now the question is, okay, we know how LLM is trained in a nutshell, roughly speaking. And now the question is how to use this LLM when it's pre-trained. Well, there are actually, I would say, 4 options in a high level. First option is just use it as it is. So it is zero-shot inference. So we do not train this LLM additionally and just use it as well, use it as it is. And it means that we do not use any data for the target task. So zero-shot means the number of data we put in for the target task. So here we do not put any target task data. Our target task in this example is movie review, where movie review is positive or negative. So given some movie review, let's say I hate this movie, we let LLM estimate whether this review is positive or negative. And without giving any data on this movie review sentiment analysis data, LLMs can estimate it is negative. And option 2 is we fine-tune this pre-trained large language models. So pre-training, what I mean is it is already trained using this billions of pairs of X and Y. And we do not use trained LLM as it is, but we fine-tune it on very small data set for target task. So recall that our target task is estimating positive, negative, or neutral from some given movie review. So let's say I give only 2 samples. First sample is negative, and second sample is positive. And after providing this quite small data set, this fine-tuned data set, fine-tuned on this small data set, for example, 2 samples, can work better than the option 1. So this is fine-tuning, basically, literally fine-tuning this large models. And option 3 is some concept called in-context learning. So actually, in option 2, we need to change the parameter used in language models. So any machine learning techniques, most machine learning techniques, they use some parameters. They define this parameter and change the parameter in a way that this task is successfully done. But actually, in-context learning does not change those parameters. This is the difference between option 2 and 3. Similarity is they use these samples. But in context learning, they put those samples in the input of LLM instead of fine-tuning LLM. So basically, they let LLM know, okay, this is the bunch of prompt we put. And first question, I hate this movie. You should answer negative. Second question, cool. You should answer positive. What about the third one? That is the actual task we want to test. And awesome, then we, fortunately, LLM outputs correct answer more easily if we give these examples what we call demonstrations. And it is called in-context learning because basically we give the context, what task we want LLM to do, and then these examples are helpful, even though we do not change the parameters of the language models. So this is option 3. What about option 4? Option 4 is something called retrieval augmented generation. So option 1 was generation without retrieval. So option 1 is just use LLM as it is. So in this figure, LLM was depicted in the parrot there, and basically some human is asking some question. And by default, it answers the question immediately, but retrieval augmented generation, the generation is augmented by some retrieval system. And this retrieval system is basically, it has some knowledge base. So for example, if you want to put some documents on legal or medical domain, then you can just put a bunch of database. So we use vector database. And those vector database, what do you mean by vector database is each element of the database is some vector. So for example, if we put some document, then those documents will be mapped to a specific vector. And another document will be mapped with another vector. And even the query, the question, will be mapped with another vector. And the system is searching over the closest document that is closest to the query vector. So we have total n vectors in the database, or n documents, and the system is retrieving the document that is relevant to the question. And the relevant document is retrieved, and afterwards, LLM gets not only the question, but the relevant document. So I was forgetting the using pointer, but let me use here, okay. So question plus relevant document is used altogether to let LLM know what is the relevant document and answer according to this document. So this is highly used in domain-specific applications. So these were 4 options we can use LLMs. Okay, this was a brief introduction of, okay, I used 23 minutes, okay. I should briefly talk about how I used LLM in mental health care domain. So first one is actually something I did with Professor Sang-hee Chu and Professor Byung-hun Kim. And it is published in JMIR Formative Research. And what we did is basically we had some transcript between patient and psychiatrist. And basically we have 1 hour long document and transcript. And we use GPT or other LLMs to analyze those transcript. And we had 2 research questions. First one is, can LLMs delineate which part of the utterances are related to PTSD or psychiatric symptoms? And we can LLMs name what is the corresponding symptom? Well, it looks quite challenging, but surprisingly we had somewhat good result. So basically, for example, the ground truth utterance is basically the red one. So this ground truth is given by some psychiatrist, and yellow one is what LLM is estimated. So you can see that this estimated part is, it includes the ground truth one. And the second question is, can LLMs summarize stressors or symptoms from an interview? So basically, we have some PTSD patients, and there's some trained interviewer. An interview between PTSD patient and trained interviewer is given to LLM, and we let LLM summarize what are the main stressors and symptoms. So we had 2 modules. First one is experience extraction module. So the PTSD patients, they have some specific experiences that causes such disorders. And afterwards, the second module is symptom extraction module. And those modules are used to extract experiences and symptoms, and afterwards, we let LLM summarize what are the main experiences and symptoms. So the result is basically, this is section estimation. The section means that in the research question 1, we estimated the patient's utterances. And this is what we call section. And basically, we define the mid-token distance, recall mid-token distance, which is normalized from 0 to 1. And 0 means that there's no any difference between ground truth section and estimated section. So basically, we have exactly same estimated section. And number 1 here means that the estimated section is none, but actually there were ground truth section in the transcript. So in the right-hand side, we plotted the statistics of recall mid-token distance, and we found that it is quite similar in many cases. So yeah, on the left-hand side, closer to the 0.0 distance is what we want. And another result is symptom estimation. So in PTSD, CPTSD, and other categories of mental disorder, we put a bunch of labels on the right-hand side. So we wanted to estimate these symptom labels. And fortunately, we reached around 80%, more than 80% accuracy and precision as well after fine-tuning. So actually, we ran on many different types of techniques I mentioned before. In-context learning is ICL, option 3 was that, and zero shot is just option 1, and the final one is option 4. So anyway, this is some observation we made regarding symptom estimation. And also, summarization was quite well done. So, ninth patient, P9, experienced some physical and mental stresses in which area, and some key experiences are summarized, and it meets the criteria for PTSD. And of course, we should measure whether the summary is reasonable or not. And basically, we found that it is reaching some high consistency and fluency and relevance. So this is some standard metric people use for documents or paragraphs generated by GPT and LLMs. And I'm running out of time, but I'll talk about the second and third one in a few minutes. So second one is LLMs for cognitive distortion classification. So we want to classify some cognitive distortions. What are cognitive distortions? So on the right-hand side, you can see 10 different types of distortions. So we found some data set containing a bunch of distortion types. And for all or nothing thinking distortion type, there were 100 different types of transcript. And similarly, we have transcript with no distortion. And in total, we have around 2.5K data sets. And for those data sets, when user speech is given, we want to know whether we have distortion or not. This is a binary problem. And we also want to classify which distortion this patient or user is having. So basically, we follow 3 steps. First one is extraction. Second one is reasoning. Third is debate. So that is why we call it ERD, named after the first letter in the 3 steps. So ERD is our method name. And basically, extraction step is we extract the part that seems to be related with cognitive distortion. And after extracting those small parts, we apply some reasoning technique. So reasoning technique, chain of thought reasoning, is quite popular in large language models, but actually we found that there was another variant called diagnosis of thought. So we also use this type of some variant that is tailored for diagnosis. So basically reasoning is something that is developed in maybe 2 or 3 years ago, which is quite popular in LLMs. And basically math and computer science related problems are something to do with reasoning. So we machine need to think reasonable to solve those problems. So that is why we added those type of reasoning steps to reason the estimation of this distortion classification. And after that, there was another popular technique called multi-agent debate. And basically, we have 3 different LLMs. 2 of them debates whether it has distortions or not, or which distortion class is estimated. And then after that, the final judge is judging based on the debate from those 2 LLMs. So we found that those 3 steps are essential in improving the performance. So basically, extraction steps actually improves the performance a lot. And debate step was also necessary, and the number of debate steps, when we increase, then the performance increases accordingly. So this was the short summary of the second one. And third one, it is under review, but our research question was, can we align LLMs with the behaviors of human expert therapists? Of course, we are not claiming that human expert therapists will be replaced with LLMs, but we want to use LLMs to help these human expert therapists. And basically, we developed a method called LLM for CBT. So CBT is cognitive behavior therapy. And we want this LLM to align with CBT techniques used in practice. So this is also work with Professor Byung-hun Kim, and basically, we let LLM know how a therapist should behave and what are basic CBT techniques. So I'm not that familiar with this concept, but basically, as I heard, down-arrow word technique or finding the automatic dots kind of thing is used in CBT. So we define these strategies and some good questions for downward arrow techniques to let LLM follow this guideline. So just putting it into this prompt was helpful to improve the performance. So our instruction leads to alignment with human therapists. So naive LLM didn't have any idea on what CBT is and what automatic dot is, and it's achieved 16% alignment with human therapists. And our therapist improved it up to 44%. And actually, we let LLM ask questions more often. And basically, it is just following the technique used in practice. And basically, we can see that LLM therapist has more questions compared with naive LLM. Of course, reflection and normalizing is what we desired, but we found that our prompt is useful in guiding this LLM to behave in desired way. So final remarks, LLMs are becoming dominant in the field of AI, and they perform remarkably well across various domains, well, including mental health care, I believe. And actually, but we have still challenges. We are in the early stages of understanding why and when LLMs work effectively. So this is something I'm interested in. And I believe key concepts in this investigation include alignment and reasoning. So alignment means that how well LLMs align with our desired behavior, and reasoning is about how LLMs reason its decision. So that's all for today, and thanks a lot. So I'm happy to answer this question. Yeah.